Hello friends, today in this lecture we are going to discuss another type of probability sampling. You would recall that in our last discussion we talked about the sampling theory, and then we talked about the different types of sampling techniques that are available to us and what is the difference between them. And now, after having discussed different types of probability sampling, we have discussed two different types, if you would recall, simple random sampling and systematic sampling. Now we are moving on to the third type, which is the probability, another type of probability sampling, which is called the stratified sampling. However, before talking about stratified sampling, I think I would need to discuss three or four new concepts, because they might be new to you. So let us discuss these concepts. One concept is about the mutually exclusive groups. What do we mean by mutually exclusive subsets? I'll give you an example. What is the meaning of mutually exclusive subset? See, suppose, let us take example of our department. So you know that there are 30 odd students in the department, and now if I divide this group into two different subgroups, that is based on gender. One would be the boys subgroup and the other would be the girls subgroup, or in other words we can say the boy subset and the girl subset. Now please understand, these subsets are basically mutually exclusive. Why are they mutually exclusive? Because if one element is present in one subset, it cannot be present in the other. If somebody is the part of the boys subset, that particular person cannot be the part of the girls subset. The opposite is also true. If somebody is part of the girl subset, she cannot be part of the boys subset. So this is the meaning of mutually exclusive subsets. So what are mutually exclusive subsets? In which there is no overlap. There is no element which is present in both the subsets. So if you are dividing a population into, let's say, 5 or 6 different subsets which are mutually exclusive, one element will only be present in one particular subset, and there would be no overlap, no common elements in any of the subsets. So this is the meaning of mutually exclusive subsets. Now what do we mean by collectively exhaustive? Collectively exhaustive mean that these subsets together, they account for the whole of the population. Now I'll give you an example to make you understand it better. Now we have divided the BBA department, all the students in the department who are studying and who are pursuing their BBA from this particular college, we have divided them into boys and girls. Now boys is one subset and the girls is another subset, and there is no third subset. If you talk about the students in the BBA department, they are either boys or girls, so there is no third subset. That is the meaning of collectively exhaustive. The subsets, when they come together, they exhaust all the units in the population, they account for all the units in the population. So there is no population unit which is not part of any of these subsets. So all the population units are part of either of these subsets. So if I divide a population in, let's say, 20 different subsets, there is no population unit left which does not belong to at least one subset. That is the meaning of the subsets being collectively exhaustive. So like I said, boys subset and girls subset, they collectively, when they come together, they account for every single unit, every single population unit in the BBA department, which means they account for every single student. So boys come together, girls come together, these two subsets come together, there is no third element left, and they together account for all the students in the department. So this is the meaning of collectively exhaustive. I give you an example of what we mean by collectively exhaustive. All the even numbers possible is one subset, all the odd numbers possible is another subset, and they together, when they come together, these two subsets come together collectively, they will account for every single natural number. So if we talk about 12 as a natural number, it will go into the even number subset. If we talk about 13, it will go into the odd number subset. So there would be no element left which is not part of either of these subsets. So that is the meaning of collectively exhaustive. Okay, now why was I talking about these two terms? And we'll again be discussing uh, the importance of these terms in stratified sampling. So what do we do first in stratified sampling? First thing that you have to do in stratified sampling is you have to divide the population into two or more mutually exclusive and collectively exhaustive subsets. These subsets basically are called strata. Strata is the plural form, the singular form is stratum. So a subset would be called a stratum and the plural would be strata. So what you have to do is you have to divide the population in different strata. These could be 2 in number, they could be more than 2 in number, they could be 20 also, they could be 10 also. So you have to divide them in such a fashion that all the strata are mutually exclusive and collectively exhaustive. Okay, another thing that you have to keep in mind is that the elements in a particular stratum in one particular subset should be homogeneous, they should be alike, they should be similar, while the elements in different stratums different strata, I'm sorry, they should be heterogeneous. What does this mean? This means, again taking the same example, we have divided the BBA students into two subsets. One was the boys and the other one was the girl subset. Here we can say that we have divided the population into boys stratum and the girls stratum. Now please understand, the boys stratum would be very much homogeneous. People would, units in this particular stratum would be almost alike, they would all be boys. So that is the meaning of being alike, being similar, being homogeneous, while unit in one particular stratum would be very different from units in other stratum. What do we mean by this? In the first subset that we had taken, boys would be very different from units in the girls subset. A boy would be very different from a girl, and that is why we are saying, that is what we mean by elements in different strata being heterogeneous. So that is the meaning of being heterogeneous. So within these strata the unit should be almost similar, which means they should be homogeneous, while across the different strata the unit should be heterogeneous, they should not be alike. So this is the first thing that you have to do. Once you have done this, once you have divided the whole population into different stratum according to these conditions, then the next step is you have to determine the size of each stratum with respect to the overall population. Now again we'll be taking the same example. Suppose there are 80 girls. Let us take an example. Suppose there are 100 BBA students, 80 of them are girls and 20 of them are boys. So I've divided the whole population of BBA students into two different stratum. One was the boys stratum, the other one was the girls stratum. Mutually exclusive, collectively exhaustive, homogeneous within, and heterogeneous across. So I have taken care of all these four conditions and I have divided the whole student population into the boys and the girls strata. Now I have to do what? I have to determine the size of the boys and the girls strata with respect to the overall population. So I'm saying there are 80 girls and 20 boys, and the overall population of students is 100, which means 80% of the population is girls and 20% of the population is boys. Is this okay? I'm doing this because in my sample also I will have to maintain the same ratio. which means in sample also I will be having 80% girls and 20% boys, which means I'll be picking up 80% girls from the 80% of my sample would be picked up from the girls stratum, while 20% only would be picked up from the boys stratum. And that is why I've done this. So now in the second step, we have determined the size of every single stratum with respect to the overall population. Now what do we do in the next step? Now you have to draw out samples from each of these stratum according to its proportion in the total population, and you have to use the simple random sampling method here. We have discussed simple random sampling in the last session that we had. So that would be the technique of drawing out samples. You would recall what that particular technique was about. So in that similar fashion, we'll be drawing out samples, but the samples would be drawn exactly as per the proportion of the different strata in the overall population. What do we mean by this? Taking the same example, suppose there are 100 BBA students, out of them 80 are girls and 20 are boys, and I have to draw a sample of, let's say, 10. So my sample size is 10. Now I will maintain the same ratio in the sample also. So the girl stratum comprised of 80% of the population, boy stratum comprised of 20%. So in sample also I would take 80% of the sampling units from the girl stratum and only 20% from the boys stratum. This way my sample will be ready. Taking the same example, I will be taking actually 8 units, or I'll be picking up 8 girls from the girl stratum and I'll be picking up 2 boys from the boys stratum. This is how I will be collecting my sample. And how do I pick up girls from the girl stratum? There are 80 girls, I have to pick up only 8. How do I do that? I'll have to make use of simple random sampling. Do you understand now how we go about stratified sampling? Okay, now we'll have to move over to the fourth type of probability sampling, which is cluster sampling, and we'll be discussing this in our next session. Thank you.